Hey guys, all right. Now this is a recording for 10.7, okay? I'm going to do some things on the video, but I do need to still go over a lot of things in class. So right now, in your own words, tell me your own definition of a function. Okay, in your own words, tell me what a function is. If you remember from Algebra 1, go ahead and tell me what the definition of function is. Write that out. Now, I'm going to save this whole thing right here, okay? This whole thing right here for class, because I do need to tell you how to use your calculator in class. I need to demonstrate that when you're around. So what we're going to do right now is just to go straight to the parametric equation definition. Okay, so what I want you to do right now is, in your own words, tell me what a function is, and then we're going to skip all the way down to the definition of parametric equations. Parametric equations. So parametric is another way to represent graphs. Okay, just one more way to represent graphs. Okay, here we go. Suppose that x and y are both, I meant to spell both given as a function of a third variable. Let's call it t, okay? And t is the parameter. T is the parameter. Hence, this is called parametric. So the two equations are x equals, okay, something in terms of t, and y equals something in terms of t. Okay, so t is the input for both x equals and y equals. Remember, these are now two equations. Okay, and then both equations, x and y equals, both have an input called t. T is the parameter. So x equals f of t and y equals f of t are called parametric equations. And I need both. So if I said write it in terms of as a parametric equation, then I need both x equals and y equals. Okay, so both of them together are called parametric equations. Each unit of t determines, so each unit of t determines the output of x comma y. Determines, each unit of t determines x comma y, okay? Which, as you can see, well, x equals to f of t, and then y equals g of t. So these are equivalency. So that's all a parametric is. So if I said write whatever it is as parametric equations, then you need to have both x equals and y equals, okay? Okay. Now in short, a parameter, okay, we talk about t being the parameter. A parameter is a special kind of variable where it is a link between x and y variables. Okay, so that's what a parameter is. So it's a link, is to connect x and y. In Algebra 2 trig, and even in first semester pre-calc, we saw a lot of projectile motion problems. So usually I'm going to give you, now you guys have to come up with your own equation. I will no longer give it to you. Projectile motion are normally objects. So projectile motion are normally objects propel upward at an inclination angle called theta. Sorry, there's an A in there. Inclination, that's not a D, but a C. Inclination angle called theta to the horizontal. I write too fast and my pen just doesn't catch up to the Surface Pro. With an initial speed, okay? And this speed, it's called v subscript 0, and that's your initial velocity. And from a height, let's call it h, above the horizontal. Okay. So from now on, you will no longer be given equation to find, before you were given equation to find, oh, where was the max height? When will we hit the ground? When will, at what time is the max height at? And so on and so on. Now you have to come up with your own equation. So here are the equations to find projectile motion questions. X equals the initial speed, which is the initial velocity, times cosine of theta times t, and t is your time. Then y equals -1/2 g is gravity times t squared plus v subscript 0, that's your initial velocity, times sine of theta, all of that times t, okay? Where t is time, g is constant acceleration due to gravity, and we are usually using 32 feet per second square, or if you see it in meters, then it's 9.8. Whoa, what happened? 9.8 meters per second square. So if the problem's in feet, most of the math questions are in feet. If you're in physics, you're more likely to use meters. Okay. All right. We're just going to do example 1 to see where you're at, and then we'll stop. We will stop the video here. Okay. Here we go. Graph the curve whose parametric equations are given. Show its orientation, super important. Find the rectangular equation of each curve, and then verify using your calculator. This piece right here, we are going to do it in class right now. We're going to do everything without the calculator. Okay. So when it says graph, you're going to start making a table, and this is what it's telling you to do. X is going to be t minus 2. Y is 2 times t plus 3, and t is restricted only from 0 to 2 seconds, and which is pretty cool, right? So if t is restricted from, let me spell everything out that I'm doing. Make a table. Now if t is only from 0 to 2 seconds, that's not too bad, so here we go. Well, at the beginning of t, okay, where's x at? So that's where we're going to plug in x. X equals t minus 2. And then we're going to find y as well. Y is 2 times t plus 3. So when we first start out, which is t equals 0, 0 minus 2 is going to be negative 2. Then when t is 0, 2 times 0 plus 3 is 3. So what we are going to try to do is graph it right here. We are still going to have x and y, but now x and y has a third variable, time. Okay, time is now on our side. Okay, here we go. 1, 2, 3, 1, 2, 3, 4. So negative 2, I need to go up 3. Ooh, let's make the y smaller. My bad. because, oh, that doesn't look very good. Okay, let me make y tick marks a little bit smaller. 1, 2, 3, 4, 5, 6, 7. Okay, so -2 go up 3. There you go. This is where it starts. It starts here. Starts. Okay. Now it says show orientation. So what that means is as time goes on, so 1 second, I have to end at 2 seconds. Okay. So 2 seconds, the last stop. Well, 1 minus 2 is going to be -1, and y is going to be, when I plug in 1 for t, 2 times 1 plus 3 is going to be 5. So -1, y is 5. 2, 4, 5. Here we go. So it went from there to there. So it said, hey, show the orientation. So you're going to need to use the arrow to tell me that you're going to go to the right. Then the last one, we are going to stop at 2 seconds. So at 2 seconds, x is going to be 0, and y is going to be, oh, why does it move? Y is going to be 7. So at 2 seconds, remember, you're not plotting time. You're using time to find x, and you're using time to find y. So we only are plotting x and y. So 0, 1, 2, 3, 1, whoa, oh my gosh, this is just driving me nuts. 1, 2, 3, 4, 5, 6, 7, there you go. This is where we are stopping. So it's traveling in that direction. So make a couple of arrows, okay, and that's what happens. It starts where I have the blue dot, and it ends at 0, 7. Now time, we are not plotting time. We are using time to make a table for x, y. Okay, so in class, I will show you how to use a calculator to check. But the next part is that find the rectangular equation of this curve. As you can tell, this curve is a line, okay? So how do we find a rectangular? A rectangular means I need x and y. So the first thing we want to write is if x is t minus 2, that's what it gives you, right? If x equals t minus 2. Then what I want to do is I want to solve for t. Solve for t because I need to plug into my y equals. Remember, it's rectangular, so normally you want y equal to something. So if I solve for t, t equals x plus 2. Now plug this into y equals. Plug t into y, okay? So your y is 2 times t plus 3, so y equals 2. We just solve for t from x. So now it gets x plus 2 plus 3, and simplify that out. So y equals 2x plus 4 plus 3. So y equal to 2x plus 7. Beautiful. This is the rectangular equation. And look at it. It is a line, and the y-intercept is 0, 7. So we are good, and we do have a slope at 2 over 1. So it is a line. In class, I will definitely show you how to use a calculator. Example B, we are going to do the same way. This time, as you can see, t is restricted starting from 0, but there's no n of that. So we are still going to make a table. T, x, and y. Okay. Since t is starting at 0, I will start at 0. Are you ready? When x is 0, 0 to the half plus 1, it's 1. When x is 0, square root of 0 is 0. Oops. Okay. Next, I'm going to use 1. So, x is, okay, what happened when time is 1? At 1 second or 1 minute, whatever the unit of time is, okay, x is 2. Y, square root of 1 is still 1. Then because y is the square root, I'm going to use nice number. Like 4, like 9, like 16, okay? And normally 4 or 5 dots are plenty. So when x, what is x one time is 4. Remember, this is the same thing as square root of time plus 1. So square root of 4 is 2, 2 plus 1 is 3, and y is going to be 2, okay? And then 1 time is 9, square root of 9 is 3, 3 plus 1 is 4, square root of 9 is 3. When x is when time is 16 seconds or 16 minutes, whatever the unit of time is, square root of 16 is 4, 4 plus 1 is 5, and then y is going to arrive at 4. And then we can go on, but we don't need to. Looks like all of my values are positive, so I don't need a lot of my negative coordinates. I'm just going to use quadrant 1. And let's do it. Are you guys ready? Remember, we're not plotting time. We are plotting x comma y. So it looks like I just need 5 units on the x. 1, 2, 3, 4, 5. Just 4 units up. 1, 2, 3, 4. 1, comma 0. This is my starting point. I'm going to use a different color. 1, comma 0 is right there. That's where I start. Okay? And then I'm just going to, looks like it's getting bigger. So 2, comma 1. Okay. And then 3, comma 2. 1, 2, 3. Right there. 4, comma 3. 1, 2, 3, 4. Right there. 5, comma 4. Okay, so, and remember, we don't stop here because the time is not restricted. We just kind of stop right here because we don't want to go any further. And we need the arrow for directional. And so if you're not listening right now and you don't have your arrow, you will get it wrong on your test, okay? Then we are going to use it to change to rectangular equation. So rectangular equation, remember we want it to be y equals, okay? So first, you're given x equals t to the 1/2 power plus 1, which is the same thing as x equals square root of t, if that's how you want to think of it. Next, we are going to solve for t. So if I were to solve for t, I will move the 1 over, so x minus 1 equals to square root of t. Okay. Then I will attempt to solve both sides by squaring both sides. So t is quantity of x minus 1. I'm going to leave that for now. I don't need to simplify that out. So now I will use y equals square root of t. Well, y equals square root of t, and t is the x minus 1. So I'm just going to plug that in. Square root x minus 1 square. The radical and power of 2 will cancel each other out. So y is going to equal to x minus 1. Now, as you can see, our y value cannot be lower than 0, right? Because when we plug this in, can you see this right here? The smallest y value is 0. So make sure we limit this right here. So if that's the case, I make sure that x has to be the smallest y value. This is my rectangular, okay? But the smallest y value has to be 0. So the smallest x value it can be is 1, like that, okay? So your domain, I should say, should be exactly what it is originally, okay? All right, next one. And also, this is another line. Okay, so this one is now back to trig. I hope you guys remember trig. Okay, so example C. You know, do me a favor. Let's change this, okay? Just to do me a favor and change this out. Change that out. Okay. X equals 2 times cosine of t, and y equals sine of t. And let's restrict the time in between 0 and pi over 2, which is the first quadrant. So we're just going to make a table. So make a table for time. Time starts at 0. We're going to use all the angles we know. So it's pi over 6, pi over 4, pi over 3, and we end at pi over 2. Then we are going to solve for x. X is 2 cosine of time. Similarly, we're going to solve for y. Y is going to be sine times time. So let's do the y first. So y is super easy, okay? Sine is 0 is 0. Sine of pi over 6 is 1/2. Sine of pi over 4 is root 2 over 2. Sine of pi over 3 is root 3 over 2. And sine of pi over 2 straight up at 1. Then we can do cosine. Cosine of 0 is 1, but times 2 is 2. Cosine of pi over 6 is rad 3 over 2 times 2, so that's going to give me rad 3. Cosine of pi over 4 is going to be rad 2 over 2, but times 2 in the front, so it's just rad 2. And then cosine of pi over 3 is 1/2, so it gives me a 1. And cosine of pi over 2 is 0. And we are going to approximate the radical 3. Radical 3 is about 1.7. Radical 2 is about 1.4. And because we already know that time is in first quadrant, so I just need first quadrant. Okay. Your x value only goes up to 2. So 1 and 2. Your y value, well, rad 2 divided by 2, this is about 0.7. And rad 3 divided by 2 is about 0.9. So I just really need like 1 tick mark. Okay, so 1 and 2. All right, here we go. At 2, I'm going to stay at 0. Okay, this is my starting location. So that's why the arrow is super important to show directional. At rad 3, which is 1.7, I need to go up exactly a half right there. Okay, so, and then at rad 2, which is 1.4, I need to go up a little bit higher than a half. Then 1, I need to go up 0.9, right there, closer to 1, but not quite. And then 0 is straight up at 1. So this is not a line, as you can see. Okay, and it goes like that. And no, I don't put the arrow on the end because it doesn't go on forever. I just need the arrow in the middle. Usually 2 arrows is fine, okay? Around 2 or 3 is perfect. I tend to do a lot more. Now, let's do rectangular equation. This is where it's going to kick you in the butt if you don't remember trig. Because we are in trig, we are going to need to recall some basic trig facts, okay? Okay, so we are going to need to remember sine square of any angle, in this case is sine square of t, plus cosine square of t equals to 1. Okay. Well, since x was given to you, I fix it to 2 cosine of t. I'm just going to solve for cosine of t. Okay, solve for cosine of t. Well, that means I'm just going to divide both sides by 2. So cosine of 2 is x divided by 2. Got it? Okay. Now that I have cosine of t, sine of t is just simply what? It's y. I have cosine of t. I'm just going to plug it in here. Because remember, rectangular is just simply rewriting it all so everything can be x and y. So sine of t is now just y squared. Plus cosine square of t is now x plus 2 squared, because cosine is x divided by 2 equals to 1. And let's simplify this out. X squared plus, I'm sorry, y squared plus x squared all over 4 equals to 1. So this is an ellipse. Yay! Okay, this is totally an ellipse. And that's exactly how you guys convert your parametric equations into rectangular. And this is the end. Example 2 says find 2 different parametric equations for each rectangular equation. So 2a, it's a line, okay? So we have y equals 8x minus 3. This is a linear. And as you guys know already, a linear doesn't have any restriction for x and y. So that means x can be anything and y can be anything. That is the same thing as when you guys are picking values for our parametric equations. So first thing is you are going to let x be anything you want it to be, okay? So you can let x be t. Now since x is t, y has to be 8t minus 3. Now both of these right here is one set of parametric equations, okay? So you need both x equals and y equals to say that it's a parametric equations, okay? So that's one of them. Now what if you don't want x to be t? Sure, Again, as long as x and y do not have a restriction, you can let it be anything you want it to be. So the second set can be, so let's box that up, but that's one set. You can have x equals t plus 1, t plus 10, t minus 100, whatever you want it to be. So let's do t plus 1 because that's kind of easy, okay? Then y equals 8x, so that means 8t plus 1, and then drop down the minus 3. From there, you can simplify a little bit. So y equals 8t plus 8 minus 3. And we can simplify that a little bit more to get y equals 8t plus 5. So your second set of parametric equation will be x equals t plus 1, and y would be 8t plus 5, and box that up. And again, no, these are not the only two. You can technically have anything you want as long as it fits the restriction of the original equation, okay? All right, guys, let's do one more of this kind. X equals y to the power of 5 divided by 2. Now, students, if you guys remember, rational exponent is exactly the same as the square root. So the denominator, it's always going to represent the index. In this case, the index is 2, which is the same as saying the square root, okay? So that's similar to x equals the square root of y to the 5th power. Now, remember, when you are asked to write parametrics, you can write it any way you want. You can be creative as long as it fits the restriction of this original equation. This original equation says, okay, well, x equals y to the 5/2, which is the same thing as x equals square root of y to the 5th. Well, because x equal to a square root of some number, the original restriction is that, okay, it can never ever be negative on x. Would you agree? Because the square root, what happens? Anything that comes out of the square root is always positive. Now, y is the input in this case, and y is raised to the power of 5, which is an odd power. Because y is also under the square root, as we know prior, what's under the square root cannot be negative either. So the restriction of the original is both for x and y, they both have to be positive. This will allow me to write two parametric equations. Let's box one right here and box one right here. Because y is the input now, students, I'm going to let y be t first. Or if you want to be creative, you can go off of what I'm doing. Okay, you don't have to do this exactly the same way. So, but my t is now restricted, okay, students, because y must be positive. So now t must be bigger than or equal to 0. Once I've chosen t, I need to plug it in to get x. Well, if y is t, then x is going to come out to be t to the power of 5 divided by 2. Now for the x, I do not need to write its restriction, because once t is restricted, x is immediately restricted, all right? Another set of parametric would be, again, I'm going to pick values for y, because y is the input in this equation. You can see that we started with a power of 5 divided by 2. So what if I don't want an exponent anymore? So if I don't want an exponent anymore, then I can have t raised to the power of 2/5. And now what's going to happen? Yes, I'm going to talk about the restriction in a little bit. But what happened when I plug t to the power of 5, 2 divided by 5 into x? Let's do the work out here. So x equals, take out the y, plug in t. Okay, now raised to the power of 5 over 2. Power to the power, we multiply the powers, right? So when we multiply the power, we end up with x equals to t. And that's okay, okay? We are going to get x equals to t. Now let's talk about restriction. Do we need to have anything restricted? We definitely do. We need to get the x restricted, because remember, x must be positive at all times. So if we don't put an absolute value around it, then it's going to be negative. Now, do you have to use an absolute value? Can you technically write t must be bigger than or equal to 0? Well, you can look at the y to see if it's needed, okay? Power 2/5, I mean the index is 5, and your time is going to be square. Now be very careful. Since the index is odd, that means y can be negative if you do not restrict your time. But, okay, here's another thing. Inside t is square. Any negative number square, it's always going to be positive. So even even we don't restrict this t, whatever comes out of this will always be positive. So on the y, I don't need to restrict the time. But on the x, make sure we put an absolute value around the time. So to make sure that x is going to come out to be positive. All right. All right, guys, example 3. Find parametric equations for an object that moves along the ellipse of x squared over 16 plus y squared over 25 equals 1 with the motion described. So for that one ellipse, we are going to be using it for A and B. Okay, so A and B are two different problems on its own. So the first thing we want to do is sketch out the ellipse. So it looks like the center is going to be at 0, 0. We have a squared equals 25, so that means a is 5, and then b squared equals 16, so b is going to come out to be 4. Now, we know the 25 is under the y square, so what that means is it's going to be vertically positioned. So go up 5 from the center, down 5 from the center, to the right 4, and to the left 4 to make our ellipse. And let's connect the dots here. We are going to use the same ellipse to complete example A and example B. Okay. Next, I want to get a different color so we can fill in what example A says. It starts at this dot, so starts here at 4, 0. It goes clockwise, that's important, so we are going to make our arrows clockwise. And it requires 2 full seconds to complete a revolution. So guys, 1 revolution means 1 period, okay? And back in basic trig days, 1 period formula is 2 pi divided by an absolute value of b. Well, in this case, it took 2 full seconds to complete a revolution. So we want to solve for b. And the reason we want to solve for b is later we're going to use our b value in our equation. We're going to cross multiply. So that's 2 pi equals 2 beta. Divide both sides by 2. As you can see, 1 beta comes out to be 1 pi. We will use that later in our equation. Now, what I want to make for you is, because I'm going to make a table. The reason is that some of us are kind of confused on this, and so a table would help you navigate this confusion process. Okay, so here's time, here's the x, and here's the y. When this object started at 0, before it even goes anywhere, right? The x coordinate is at 4 and the y coordinate is at, I'm sorry, not 0, it's 5. Sorry, not 5, I meant 0. Duh, I just put that on the ellipse, and now I'm writing something different. Well, what does that mean for a full second to finish? That means 1 second later, I'm over here on the opposite side. I'm going to make a 1 second mark here. Well, that order pair is -4, 0. Okay, then where am I when I'm at a half a second later? Half a second later, would you agree I would be here at the bottom, and that order pair would be 0, -5. So x would be 0, y would be -5. And 1.5 seconds later, I'm here at the top. 1.5 seconds later, I'm at the top. So that order pair, 1.5 seconds later, that order pair would be 0, 5. So where would this object be 2 seconds later? 2 seconds later, it's back to where it started, because it said it took 2 full seconds to finish a revolution. Okay, how is that table going to help us? When you guys are writing parametric equations, you always going to have an x equals and a y equals in terms of t, okay? So I'm going to give you the general formulas for these type of questions. You will have an x equals, you will have a y equals, and you're going to have an a value in the front for both, same a value. Now we are going to use sine of beta times t, and over here we're going to use cosine of beta times t, or okay, x doesn't have to be sine, they can switch. X equals y equals a cosine beta times t, and over here a sine of beta times t. So as you can see, x can be a sine function and y can also be a sine function, or vice versa. So make sure we understand when to use what. Now for our problem 3, we started at 4, 0. So that means when the angle is 0, we have an x value at 4 and a y value at 0. Out of these two trig functions, the sine and the cosine, only would actually give us a value that's not 0 at an angle of 0. So for this problem, x would be something cosine something in terms of time, because we've already determined that x is going to be cosine, then y must be sine immediately. Okay, now again, if this is confusing, I want you to listen to it a couple of times. So we have to fill in our a and our b value. Well, we found b already earlier, so b for this problem will be pi. How would I know what the amplitude is? Well, the amplitude, when x, okay, again, before the object starts moving, it was positioned at 4, 0. So this 4 right here, think of it as when the angle with time is 0. Well, pi times 0 is 0, cosine of 0 is 1. I would need to multiply the amplitude by 4 to get a position of 4. Now, what do I do with sine? This is a little bit trickier then for the y, right? At a half second later, remember that, at a half second later, we have a y value of -5. So what does that mean for time? Time would be a half, so we want to check, right? Half times pi, that's pi over 2. So sine of pi over 2 is now actually 1. Well, 1 times something. What is this a value? What a value must I have so that way I am going to end up with a value of -5? Well, obviously it has to be -5. So that's how we have to come up with these values for our two parametric equations. So that's it. Box it up. Now, if that's confusing, again, listen to it again. I'm going to do B again. I'm going to do B, so hopefully at the end of B, you have a better understanding of how to complete these type of questions. All right, so I've already drawn out the ellipse, the same exact ellipse that we were using earlier, but I drew it out because to save you guys some time. So for this question, it says the motion begins at 0, 5. So let's go up here and write starts here, right? At 0, 5, because that's 0, 5. All right. It's counterclockwise, so we have to make this arrows to see what direction we are going, and requires 1 full second to complete a revolution. Remember, guys, a revolution means 1 period, and the formula for the period is 1 period, it equals to 2 pi. Now, let's just write it. So let's just solve for beta. Now, 2 pi over b equals 1 second. That's what I meant to say. I'm sorry. So 1 period equals 2 pi over b, which for our problem, it's 1 second. Earlier, 1 revolution was 2 seconds, so we took 2 pi over b, and then we said it equals to 2. When we solve for beta, we can cross multiply. 1 beta comes out to be 2 pi. So b comes out to be 2 pi. We will use this later to fill in our equation. Now let's make a table, because some of us can see a little bit better with a table. You don't have to make a table. I'm making this so you can see where I'm coming from with the values. At 0 seconds, right, x is 0 and y is going to be 5. A half second later, because it took the entire second to go all the way around this ellipse. So a half second later, I'm going to skip myself a space. X is 0. Now y is -5. Now how about a quarter of a second? So a quarter of a second later, as you can see here, x is -4. So a quarter of a second later, x is -4, and y is 0. Then 3/4 of a second later, I'm on the right side. So that means x is now 4 and y is 0. And 1 second, I'm back to where I started. So now let's see. Remember, we talked about this earlier, right? Only cosine is going to give you a non-zero value when the angle is 0. Okay, again, we only have two choices, right? Either x equals sine or x equals cosine. Whatever x is already in use, then y gets the other. So for our case, okay, again, for our case, currently the y has a non-zero. So y will immediately get cosine. Okay, that means x will get sine, just like that. So make sure you understand how we choose what gets what. We have the beta value. We can fill that in immediately. So x equals blank sine beta is 2 pi, so 2 pi t, and y equals blank cosine 2 pi t. Now, what is the amplitude for x and y? What's the a value for each equation? And no, they are not the same. They don't have to be the same. They can be the same, but they don't have to. So for the y value, when the angle is 0 or when t is 0, so let's focus on when t is 0 right here, y'all. When t is 0, we can plug it in to see what we need. Y equals blank cosine 2 pi times 0. Well, that's really 0. Cosine of 0 is 1, but I need it to be 5. So this has to be 5 because only 5 times 1 will give me 5. So 5 goes in there. Okay, now let's go and see what we need for sine. Again, I can't really plug in t for 0 because t is 0, 2 pi times 0, right, is 0. Sine of 0 is 0. That's not really helping me because 0 times any number in here, that's going to be 0. So right now, when the time is 0, it's not helping me at all. But I could go and pick pi over 4, pick the next value that can help us. So we are going to plug in when time is pi over 1 over 4. So 1 over 4 times 2 pi blank. So that's going to give us a pi over 2. Sine of pi over 2 is 1. What value would we need to plug in the blank spot, which is the amplitude, to give us an output of -4? Well, only, obviously, it has to be -4, right? So our amplitude for x is going to be -4. So now we have our two equations, students. We can highlight them, box it up. Those are the parametric equations that we needed for this example. Let me pinch it in. So here's example 4. So honestly, example 4 is much easier than example 3. Graphing parametric, it's really easy. Okay, all you got to do is make a table. Given the parametric equations of a curve, x equals sine of t and y equals cosine of t, and we are only picking t values in between 0 and 2 pi. So as you can see, I've already done the table here for us. The reason I did all of this ahead of time is to save us some time because I'm always counting. I feel like I'm counting tick marks with you guys, and that's a waste of time in recording. Graph it and indicate the orientation, and that's super important, okay? So you make sure you tell me what direction it's going, because as you saw earlier with example 3, we can go clockwise or counterclockwise. So we are going to fill in x equals sine of x right there, y equals cosine of t right there. I'm sorry, x equals sine of t. y equals cosine of t, and the time is in between 0 and 2 pi. Now, why did I pick just 0, pi over 2, pi, 3 pi over 2, and 2 pi? All I need you guys is to give me 5 inputs to get 5 outputs for each x and y, all right? Normally, I pick the angles that's easiest to calculate. So sine of 0, okay, so when t is 0, sine of 0 is 0, so this one's 0. When t is 0, cosine of 0 is 1. When t is pi over 2, sine of pi over 2 is 1, so now x is 1, then cosine would be 0. When t is pi, sine of pi would be 0, and cosine of pi would be negative 1. When sine of 3 pi over 2, that's negative 1, and this is 0. Sine of 2 pi is 0, and cosine of 2 pi is going to give us 1. So as you can see, the x and y values are all just zeros and ones. So if you think of it, you can just make this an order pair if that's easier for you to see. You don't have to. You can just look at the table. Just like that. And all you got to do is plot those 5 points. Are you ready? 0, 1. Bam. That means, oop, I just plotted it wrong, didn't I? Not bam. Don't do that. Erase. Erase the bam. 0, 1. So that means I'm starting right here. All right. I'm starting right there. Now we're going to go 1, 0. 1, 0. Oh, can you guys see? I'm going this way. I start on the top. My next dot, when the time is pi over 2, I'm on the right side. Then the time is pi. I'm 0, negative 1. Whoa, look at this. Look at the direction I'm going. That's why I'm using the arrow to indicate the direction. Now, if the table goes left, then you got to make the arrow on the other side. At 3 pi over 2 is negative 1, 0. Bam, there you go. And my last dot at 2 pi is back to where we started. So this is where we start, and this is where it ends as well. So start and end in the same exact spot. And according to the dot or the table, we are going clockwise. Okay, and that's all you gotta do. All right, guys, so example 5 says projectile motion. Now, in this unit, you guys only had 2 definitions, right? One was the parametric equations, and then the second was the projectile motion. In that definition, you were given 2 equations. So let's write them down because we are about to use it soon. You were given x equals v sub 0 cosine of theta times t. And the reason we have 2 is because we're in parametric mode. In parametric mode, it's always 2. X equals in terms of t and y equals in terms of t. So y is negative 1/2 g times t squared plus v sub 0 times sine of theta times t, and then plus h. Now, if we're hitting from the ground, h is usually 0. G, if you guys remember, it was defined as the gravity, and we either use 32 feet. G, it's either 32 feet per second square or 9.8 meters per second square. Now you have to look at the unit of measurement to know which one to use. Okay. Now what exactly was v sub 0? That was your initial velocity. All right. So let's see if we can use it right away. Suppose that Jim hit a golf ball with an initial velocity of 150 feet per second at an angle of 30 degrees to the horizontal. Find parametric equations to describe the position of the ball as a function. So as you can see, this guy, he is hitting a golf ball, and it's going to eventually go up and then down, just like that. So our job is to find the position of the ball in parametric. So x equals, we were given the initial velocity is 150, so that's v sub 0. We plug it in for v sub 0. X is cosine of theta. Theta is 30 degrees, so we're going to plug in 30 degrees, and we keep t as our variable of input. Y is going to be negative 1/2 Gravity, in this case, because it's using feet, so we are going to use 32. So times 32. And t is going to be maintained as t squared. Now, again, the initial velocity is 150. Sine of theta, theta is 30 degrees. And keep t as t. Now, because he is hitting the golf ball, normally you hit it on the ground. So now height is technically 0. You don't need the 0. You can just leave it out. We do need to simplify this down. So let's try to get this out, okay? All the way over here. All right, x equals, well, cosine of 30 degrees, guys, is rad 3 over 2 times t. And so down here, negative half of 32 is negative 16 t squared. Sine of 30 degrees, guys, is going to be 1/2. So now plus 150 times 1/2. So our final equations, students, for the parametric would be, ready? X equals 75 radical 3 t. Y equals negative 16 t squared plus 75 t. Do you guys remember in Algebra 2, whenever you guys are working with a parabola question, you always had that negative 16 t squared somewhere? Well, this is where it came from, okay? Part B, how long was the golf ball in the air? Okay, so I want you to think about this. How long it was in the air depends on when it lands, right? So at some point it's going to land on the ground. We know that much. So what we're thinking about is we have to find the time that the ball is on the ground. All right? Well, the ball is on the ground is when, that means we're talking about the vertical distance. So out of the two parametrics here, we got the x equals and the y equals. Y is going to give us the vertical distance, and the x equation will give us the horizontal displacement. So we are going to use y equals negative 16 t squared plus 75 t. And we want to know how long was the golf ball in the air. We want to set it equal to 0. Then we want to solve for the time. Are you guys ready? To solve for the time, we would want to factor out a t, because that's what they both have in common. So now negative 16t plus 75. Set each factor equal to 0, t equal to 0, and negative 16t plus 75 equal to 0. Well, t equal to 0 makes sense because when the t is 0, meaning that it started out at 0 time, the ball is on the ground. Hence, we are putting it, the height y equals 0 on the ground. Now, let's solve for the other t. Negative 16t equals negative 75. Divide both sides by negative 16, so that will give us 75 over 16, which is about 4.69 seconds. If I ask you in the exact fraction format, then you can leave it as 75 over 16 seconds. If you were asked to round, then you can round it to 4.69 seconds, depending on what it's asking us to do, okay? When was the ball at its maximum height? What is the maximum height? Well, as you can see here, the maximum height is over here, okay, just like that. So what we want to do is find the vertex in this case. And I hope you guys still remember the basic equations from Algebra 1, maybe Algebra 2. So the vertex, oops, why is it erasing as we are writing? Let's go up a little bit. There you go. So the vertex equation, the x-coordinate of the vertex is negative b divided by 2a. And yes, we are still using the equation y equals negative 16t squared plus 75t. So let's plug it in. Your b value is 75, so that's negative 75. 2 times a is negative 16. Okay, so that allows us to have 75 over negative 75 over negative 32, which will give us a positive a positive answer. Now again, if you were asked to leave it in the simplest fraction form, you can leave it like that, or you can round it out if it's asking for rounding, okay? So 2.34 seconds is the x-coordinate of the vertex. We do have to plug that in. So y equals -16 times, I always plug in, and you should too, the exact value. Round only at the very, very, very end, okay? I'm going to use my calculator to punch all of that in, and let's see what that, just give me a second to enter that in. So you should really practice as well entering all of that in to see if you get the same exact fraction as I do here, okay? And if we were to round that out, guys, I would have 87.89. Now let's write that correctly, okay? When was the ball at its maximum height? What is the maximum height? So the maximum height, max height, is 87.89 feet at 2.34 seconds. And again, I could ask you to leave it in the exact form. If I do, then just give it to me in the fraction format. All right, students? Determine the distance that the ball traveled. Now, this is the horizontal displacement, which requires us to use the x equals equation earlier. And if you guys remember, it was x equals 75 square root of 3 times t. Well, determine the distance, right? That means it wants to know how long, how far out did the ball travel. We already found when it hit the ground, right? How long was the ball in the air? It's the same thing as when does it hit the ground? Okay, well, we found it's going to hit the ground in 75 over 16 seconds. That's what we're going to plug it in. And again, same thing. Do not round until the very, very end. So I want you to plug in the exact value until the very end. So now we can round, and it's 608.92. And then we want to use the correct unit of measurement. If it's feet, you write feet. If it's second, you write second. If it's degree, you guys write degree. The only time you don't have to write is when it's in radians, right? Now this part right here, I'm going to skip this, okay? We don't have to do this year just because we are remotely and it's kind of difficult for me to show you my calculator. Guys, you should be so excited right now because we are on the last example. Woo woo. Okay, let's do it. Tanya, who is a long distance runner, runs at an average speed of 8 miles per hour. 2 hours after Tanya leaves her house, you leave in your car and follow the same route. If your average speed is 40 miles per hour, how long will it be before you, okay, catch up with Tanya? Use simulation of 2 motions to verify the answer. We are going to skip this this time. Okay, so let's write Tanya over here, and we're going to write you in your car over here. It's looking for parametric equations, so we are going to give this just like that. Let's write x1 and y1 since we are going to have 2 things going on at the same time. Now, Tanya runs at 8 miles per hour, so her x horizontal displacement is 8t. Okay. Now, you are in your car. You leave 2 hours later, though, so be mindful. You leave 2 hours later. So if Tanya leaves at 1 o'clock, okay, you leave 2 hours later than that. So we're going to minus 2 hours for you. And your car has an average speed of 40 miles per hour. Now, since we are only interested in horizontal displacement, student, your y equals doesn't matter. Your book, okay, I'm going to spell it out. Your book tends to use 0 or 1. I'm going to put 1 over here and 2 over here to show you that it doesn't matter. So I'm going to write y does not matter for this problem, since height is not important, okay, y is the height and it's not important. Okay, now the one thing I do want to make a mental note for you guys is that in years past, when we would use a calculator to do simulation of these, we give the y values two different values, so we can see on our calculator which one's Tanya and which one's the car. Now, because we're not actually doing the simulation in the calculator, you can pick y sub 1 equals 0, y sub 2 equals 0. It doesn't really matter, or they're both 1s or they're both 2, okay? Just be mindful of what those are. All right, so catch up, question mark. Okay, to catch up, they have to be exactly the same place. Same place means same horizontal displacement. Let's solve for t. So that's going to be 40t minus 80. We're going to subtract 40t from 8, so that's going to be negative 32 equals negative 80. Divide both sides by negative 32, so t is going to come out to be positive 80 over 32. You have to reduce. When you reduce that down, it gives us exactly the perfect decimal place, or you can put in fraction if you like, 2 1/2 or 5 over 2, okay? So, but t represents hours, right? T is hours later. So make sure we want to be cautious. But it doesn't say, okay, again, it's not asking when did Tanya left. It's asking when you, okay, in your car, catch up to Tanya. So we have to subtract 2 hours to get a half, okay? So you will catch up with Tanya in half an hour. And that's it.